All right, heads up everyone, because this part is going to be a little different. And it's probably the last major hurdle before we start having some real fun with this. So what you'll need to know is that a surface normal is essentially the z-axis of a surface, no matter what orientation it's in. And it's technically at any point on the surface as well. Referential z-axis, I guess you would say. Yeah, that's tough. Anyway, so basically, I'll pose you a question so that you can kind of understand why it's necessary first. So if I minimize this, I'll turn this back on. What do you think will happen if I rotate the surface to the vertical plane, right? Because we're trying to map this onto a building, right? So right now, you see in perspective, it's horizontal. But I want to put it on the side of a building. So can I just rotate the surface vertically? What's that?
Wouldn't it only be 2 feet?
Yeah. Well, sort of. Well, no. So the idea here is that you want to keep that's kind of a larger discussion. You want to keep as much geometry as you can in Grasshopper until it becomes necessary to push it out into Rhino. Because then you can't modify it very easily once it's in Rhino. So I'll show you, rather than wasting time hanging out debating. But so when you rotate it, right, all I do is just, you would think it's like a tilt-up building. You just pour the concrete and then you lift it up into place, right? So I lift it up, boom. This is what happens. All the geometry collapses. And if you notice at the top of it, you've got a little 2-foot band of extra stuff. Why do you think that is? Because what? Anyone?
It still exists in a flat plane, not a vertical.
Right, exactly. So Daniel said it still exists in a flat plane, or in the XY plane, instead of a vertical plane. So this is where you could technically just switch the direction of the extrusions. And that part's really simple. You basically just take this and replace it with a unit Y. That would work. So I go to there and I say unit Y, and I'll put it in like this, and I'll plug that into D. You don't need to do this. Don't do this. I just want to show you. So there's unit Y. But the problem here is that in the unit Y direction, oh, this is actually straight. Okay, yeah, so that works because my plane is actually straight. But our buildings are not exactly in the X and Y direction. So we can't do this in all cases. If this is slightly rotated, like a lot of our buildings are, then the problem is it actually extrudes at an angle off of the surface because it's only going in the Y direction wherever the Y direction is, regardless of where our building is. Does that make sense? So what we need to do is find a surface normal, which wherever this thing rotates to in 3 dimensions is going to have the same orientation based on the surface itself. So it looks like this. This piece of paper, right? Right now it's flat. The surface normal is if you take a pen and you put it on the paper like that. That is the direction of your surface normal. If I rotate this thing this way, that's the direction of the surface normal. If I bend it like this, then wherever I place this pen on it, that becomes the surface normal in that place of that surface at that point. Does that make sense? Visually? Okay. So when you're thinking about the power of Grasshopper, and now, just try to soak this in. When you're thinking about the power of Grasshopper, it's that no matter what I do to this thing, I could make it a saddle, I could make it a parabolic, a hyperbolic parabola. I can find a surface normal anywhere on that crazy surface, and I can map something to it or orient something to it. That's the real power that you have here. So to find that, remember I mentioned something to you before about normals. There's that little string. We'll get there, but let me just get rid of that one. So here's what we need. We go to, well, we're still going to use extrude, right? So we're going to find extrusion direction, right? It has direction and magnitude. Now, you'll notice that a normal is nothing more than an axial direction. So once you find the normal, all you have to do is feed it the magnitude. And this one I just have to give you. It's not apparent. So under surface analysis, we have these two ones that are pretty much, at least for our purposes, always going to be paired up together. I don't think I'm going to use them at all without it. So it's called evaluate surface under surface analysis, and then surface closest point. So these, I'm going to mark them for you. No, you don't. This is, the normals are going to take care of the axial orientation. So here's what we have. We have surface closest point, which, don't worry too much about the description. It says finds the closest point on a surface. But then you also have this one that's called evaluate surface. So it says it's going to evaluate the local surface properties at a UV coordinate. So it doesn't matter if it's flat or rounded or warped, a UV coordinate is going to be your 3D version of the X and Y axis. Now, the more important thing to understand, at least download into your brain so that you know it, is that these two actually will map UV points and give you a normal at whatever point you want. So what it's asking for is either a surface or a point. And then it has a couple of output values that gives you the closest point, which we're not going to use, the UV points, and the distance, because it'll actually measure the distance from points to the surface, and that's where it's going to establish this closest point. That's not relevant to us right now. What is relevant is that we have the UV feed into the UV input of the evaluate surface. And then what we need to give it is the original surface and then the evaluate surface right there. What are we missing? Sorry. Input parameter P. Oh yeah, I think we need the centroid. Sorry. So what it's going to do is it's going to take wherever you locate a point on that surface, and that's where it's going to find the normal. So the logical choice for where to locate your normal on a plane flat surface is going to be at the centroid. And that's found by going to surface analysis area. Remember I showed you guys that before? I don't expect you to remember it, but... So this gives us the centroid of the surface, like that. And then it gives us, if you pull the centroid into the P, right there, it gives us now, take a look at this, a plane on that surface. So why is that significant?
It just shows you that that's now the direction you're operating in. Like whenever you insert another surface or object.
Very good, yeah. So that's saying that it has established a new plane, which in this case is actually output via the normal frame, actually. Sorry. So it outputs a new UV frame, which is a base point. That's in a brand new orientation that when I rotate this surface is going to rotate with it. So I can pull this. I don't want to do that, actually. I want to do, boom. So now see how that still maps with the surface there? You guys see that? Okay. So here's the cool part. At this point, what I have is a normal. The normal does not necessarily have magnitude. But what we can do, let me see, vector. Amplitude. Yeah. Yes, I think we want amplitude. So what we can do is go under vector and vector. It's redundant, but and then you go to this one called amplitude. So it says set the amplitude or length of a vector. And so this one is going to allow you to feed in both a vector without magnitude and then feed in the amplitude, as a numerical value. So we've got our normals, and then we have our amplitude, and then we get a vector which we can feed into D for both. And now you can see that no matter what orientation this surface is in, it's going to extrude it in that direction. Okay, so I went through a lot. So what I'm going to do here is kind of walk through it with you again. Let me turn this off real fast. Okay, so where we began this. At first I had the unit Z in here. What I did is I replaced unit Z with all of this, right? So all of this right here replaced unit Z with what I would refer to probably as unit N. So if I could just group all of this together and minimize it to a tiny little tab that says unit N for unit normals, I would. I think there's a way to do it. It's probably an add-in. But basically, this is a package. You can write this one down explicitly and keep it because it's very powerful.
That just explains the angle that your plane is at now.
Right. Yeah. So I'll walk you through it. Basically, it's saying I'm going to find a point on a surface. Point surface. I'm going to take the UV orientation of that point on that surface and evaluate it, which is going to give me a normal. The normal replaces the direction part of the vector, direction and magnitude, and we keep the same magnitude. See a lot of stairs.
So can you take that normal now, and then, okay, so this is just for one surface. So let's say you want to apply that same facade to like 10 different buildings. Would you just do attach from that end to all your different objects?
Yeah, sort of. In fact, I can show you that really fast. So,
Or you just set up
we can move it?
sorry, what?
How we can rotate it?
Yeah, you should be able to just rotate the surface. Like this one can now, well, I hit it, but you can just rotate it anywhere and it'll work. But basically, so I think rather than starting a new video just for this, I'll finish off with this point. is now if I want to clear the values of that surface, I can start mapping it onto the surfaces I already have. Oh, well, I already cut a hole in that one, but do I still have? Yeah. All right. So at that point, all I have to do is just start mapping multiple surfaces, and it'll work. So I say set multiple surfaces. I pick that one, pick this one, and this one, and hit enter. Uh-oh. Oh, wait, hold on. Explode. That one, that one, that one, that one. There we go. I got an error. Interesting. Theoretically, that should. What's that?
So it looks like some of the windows are overlapping.
Ah, flatten. Ha! Oh, darn. So I flattened it. I think this probably needs to be flattened too. Alright. Well, now it's just trying to figure out the error. Trimming the UV domain. For reference surfaces. Well, theoretically that should work. But anyway, I'll take a look at this here when we stop the video. But what I'd like you to get to is instead of, I'm going to leave that up for you, but let's just map one for now, and I'll figure out where I'm going wrong. So just take this and say set one surface and put it on the side of your building. Oh, explode. There you go, like that. Okay, so that's the goal to get to. Let me leave this up for you, and then we'll take another break. It's 9:30. Dang. Has Jeff been keeping you guys here until like 10:30? Yes.
I have something. What is that?
It's not computing something. Right click anywhere.
Oh no.
Yeah, and recompute.
Yes.
needs to feed into the D value of the extrude. Both of them.
That one?
Yep.
For both?
Yep. Yeah, because now what you did was you replaced the unit Z that was going to in the Z direction with in whatever direction the normals are.
Something is wrong with this computer. This
Grasshopper can get slow.
yeah, it's still slow.
Well, these computers also are terrible. So. Are you trying to reference it on that surface or a building surface?
No. Where's my button?
Good. Do SEL ALL.
A?
S for SEL
I did so.
and then ZS others.
Okay, you got
Yes.
huge table.
So I have to reference the one first one?
Are we standing?
Yeah.
To make it right?
Hmm?
Do
Everything's
I do
standing.
reference?
Yeah. Yeah, just put it on one surface. So you're gonna have to explode it though.
That's all.
So for
Up, down.
the surface?
Yep. Yeah, but you have to explode that first.
That one's hidden.
All is hidden, right?
And then escape to
They're all
deselect it.
hidden?
Then set your steps.
Okay, I'm on the phone. Can you find selected?
Just pick one side. Is that view?
How it's
And right.
selected?
What you doing?
It's selected.
That's right. Computer does
Yeah, I'm doing this. See? I'm pointing it and so.
So when it says that,
Well,
it's because it's a poly surface, and you can only select one right now. So, whereas
Select that.
Control V. Why you
and then set one surface.
Could we move that to origin? But I guess something this was sound going off.
What? Yes.
Why is not select that one? Because I had this issue.
How can you select it?
Yeah.
Because there's nothing to select, it's a grasshopper geometry.
Oh.
Are you trying to
But I
select the
guess-
surface
Yeah.
that it's referenced to?
Make it
Yeah,
stand
he
up.
wants to.
Yeah,
rotate it.
so you have it turned off right now, so you need to go back into Rhino and turn it back on.
This wire is solid or extrude?
I don't believe it.
Should
Extrude.
be landscape.
Fine.
Look at color.
There you go. Now you can set it. And rotate it and move it and stuff like that.
The red one.
Alright, so in theory, basically you should just program that surface, throw it on one of the sides of these buildings, like you did there.
Right.
You're doing the same thing, so why can't I do both?
It has to be exploded. The surface has to be exploded. So select it. No, yeah. You see how it's a poly surface right now?
Right.
Type in explode
Yes.
and now escape. And then do set one surface. There.
What is the difference between it being a poly surface and exploded?
If you reference it in to the surface parameter, the simple one, then it's reading as a poly surface and it's giving you an error because it's not a surface. It's a poly surface, which would essentially be a beater.
Okay.
If you explode it and you select one, then it's one surface or a set of single surfaces.
Right. I
Um,
agree with it.
yeah, but I'm going to show you how to transition it to work with a full body.
Oh, okay.
just toggle back and forth between numbers, or like a key, like a hotkey or something. Because
I don't know.
my U count for some reason was like all the way up to 200, so I actually went like all the way that way, and it just stopped responding to the program.
I see. Yeah. So the best way, if you're dealing with a lot of data like that, it can slow down very quickly. So you can double click a slider to change the value. Double click. Oh, sorry. The value. Like double click. What? What the hell? It's supposed to be doing it. That's weird. There. I don't know what I was doing wrong. I guess it's not actually on. Whatever. So if you double click it and change it to say 5, then it'll compute a little faster. Because when you slide it, it's trying to recompute it every single time. The other thing you can do is right click and turn off lock solver, and it stops computation until you've reconstructed something, and then you can unlock it, and it'll go
Oh, okay. So you can make changes
without it
and when you
computing.
take it off.
Yeah.
Sweet.
Okay. So there's not too much more I want to go over with you guys, but I do want to try and close the book on most of this, at least for the simple geometry. And we'll worry about the more complex stuff later. So let's get going. Oh wow, I left the recording on that time. Whoops. I'll chop it down for you guys.